Hello everyone, let me know if I am audible and if everything is visible. If anyone can drop text like I'm audible or not. Okay. Okay, so I'm starting now. I hope I'm audible and the screen is visible to everyone. Just let me know, just like 2 to 3 people, if they can write down that everything is fine. Okay, so first of all, let me introduce myself. So myself Shashank Pathak, and I'm currently working as a software engineer at Inference Labs. Previously, I was SD1 at ClearText and I interned at Red Hat. I was the ACM ICPC 2019 regionalist, and I have approx like 1+ year teaching experience as well. And the subjects which I'll be taking is DS and C++ and interview preparation. Okay. So you can take the Unacademy Plus subscription and you can use the code SPARTAK10 to get 10% off on Unacademy Plus subscriptions. So the benefits of taking this is you will be taught by India's best programmers, and the classes will be live and will be interactive. You will have doubt support, and for practicing problems you will be using CodeChef over there. And there are new batches on Unacademy which are Transpire, Eklavya, Brahmastra and Mahayodhya. So they will be dealing around, Transpire will be dealing around OSDBMS and networking master course, and it will be a duration of 1 month. Eklavya will be a course on programming for beginners and it's of 8 months. Brahmastra 3.0 will be like 5 months learning track for college and off-campus placements, and the last will be a 6-week master course on advanced programming topics. Okay, and its duration is also 2 months. Another good opportunity for people like for all the learners out there, and that is Bugs Bounty. So if you report like any inappropriate content you find in the video, and if you're the first one to report that, so you will be rewarded for the same. So okay, yeah, so just report any inappropriate content, so use the form in the description out there. Okay, and yeah, at the last, like, do like, share and subscribe, and so that you will be able to get the notification that yeah, the new video is there, or a new video is scheduled. Okay, so this is all. Let me know if it's good to start. Just drop a yes if it's good to start. Okay, fine. So today I will be taking LinkedIn interview problems. Okay, and the problem is house robber, and it's a medium lead code problem. Okay, you can consider it as a medium level problem. So yeah, let's see what the problem is, and let's begin with it. Okay, so let's start with the problem statement. So the problem statement is we are given basically you are a professional. I will be first reading the problem statement, and then we'll be discussing the solution, and I will take your approaches as well. Okay, so the problem statement goes like this. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. Okay, the only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police. Okay, if two adjacent houses were broken into the same night. Okay, so basically we are given an integer array nums. Okay, representing the amount of money each house has, and our problem is to return the maximum amount of money we can rob tonight. Okay, without alerting the police. So this is the problem statement. So you can take like 1 or 2 minutes to think of the approach. Okay, so anyone who has any approach around there? Okay, just before you can think of your approach, let me just explain you one sample example. So suppose over here we are given 4 houses. Okay, and each house is having 1, 2, 3 and 1. So these are the ith element in our array will basically represent the amount of money each house is having. Okay, so the first house is having amount of 1, the second is having an amount of 2, third is 3, and fourth is 1. Okay, so you can see the maximum amount of money we can take or we can rob from these houses is 4. Okay, so how can we do that? So we can take the first house and the third house. Okay, so the first and third house if we take, so the sum will be 4. Okay, we can't take the second house. Why? Because then 2 and 3 will be adjacent and 1 and 2 will be adjacent, and over here it's written that if 2 adjacent houses were broken into the same night, so the police will be informed, and we can't basically it's a restriction that we can't choose 2 elements in our array that are adjacent. Okay, so this is the answer for the first one. Okay, and one more thing, we can't even choose the third house and the fourth house, though they give the same sum as 4. The reason being the same, because we can't choose any 2 adjacent elements. Okay, so let me take another sample example as well. So it says we have 2, 7, 9, 3 and 1. These are the elements in our array, and we have to take out the maximum sum such that no 2 adjacent elements are there. Okay, so here we can rob the house 1. Okay, we can rob the house 3 and the 5th house. So the first, third and the 5th one, first, third and the 5th one. So the sum comes out to be 2 plus 9 plus 1, and that is 9 plus 2, 11 plus 1, 12. Okay, so the maximum amount is 12. Let me know if the question is clear to everyone. Just write a yes if the question is clear. Sum of odd in even position house and find max Bohnish. Okay. Okay, Mrinal, you skipped the intro. Okay, so currently I'm working at as a software engineer at Inference Labs, and previously I was working as an SD1 at ClearText. Okay, no worries, no worries. Yeah, I can see approach that do the sum of odd and even position house and find max. So no, this is not the correct approach. Think of something else. Just let me know if anyone is having any doubt in the question or in understanding the problem. Okay. Then we will start discussing the approach. This question was it was asked in LinkedIn interview. So I don't know whether it's a code-shape problem or not. Okay, so more approaches, like if anyone is having any approach, they can send me. Just think of the very brute force approach, like don't think of any optimization right now, because correctness is very important, right? This is an interview question. No. No, Digvijay, like inference is not a subsidiary of LinkedIn. It's just a LinkedIn interview problem which I am discussing. Okay, so shall I start with the approach? Shall I start discussing the problem? Just give a yes or a no if I can start. Okay. And if at any point, like if you are not able to understand anything, just write down over here. I will be looking at it and we'll take it up. Okay. Okay, cool. So if I see the problem, so what my problem says is, so it's like we have, suppose, n houses, right? N houses, and in each house the amount which is there, I think it's a recursion and we can optimize it with DP. Yeah. So right now I'm explaining or discussing the approach, so I won't be able to look at the chat. So after that I can take that. Okay. Yeah. So basically we have n houses like this. Okay, and each house has a certain amount of money in it, and we can't. So what is the restriction? Restriction over here is that we can't choose two consecutive houses. Okay, two consecutive houses. Now, can I reframe my question? Like if someone asks me the question, so just can we boil down this question in this manner, that we are given an array. Okay, we are given an array and we have to find that subsequence. We have to find a subsequence such that it is having no two adjacent elements. Not, I'm representing like this, not two adjacent elements. Okay, and the sum should be maximum of that subsequence, and sum should be maximum of that subsequence. Okay, Can I say that? Can I say that my problem statement wants me to do this? That I have to choose a subsequence such that it doesn't have any like two adjacent elements or consecutive elements, and it should have the maximum sum. Can I say that? Sahil, this question is not like your solution pick only alternate houses is wrong. It's not right. Okay. So what can be our first approach? What can be our first approach? And that is the very brute force approach, which I can say. What can be the brute force approach? So the brute force approach would be to create all such subsequence. Okay, create all such subsequence and find the maximum sum which we can get. Okay, so let's suppose this is our function solve, which is taking the nums array. Okay, I'm just writing a pseudo form. Okay, right now pseudocode, and the number of houses n, right? So what basically happens in recursion? If you see, there will be some base cases. Okay, there is a base case which determines the termination, and what we have to return the maximum sum, so its return type will be int. Okay, and there will be some recursive calls, right? There will be some recursive calls. Okay, so let's see the base cases. Okay, let's see what can be the base cases. So suppose if and yeah, we will be passing this n as n minus 1, because if we consider our array, so it's like 0 1 2 3, right? If it's of size 4, so we'll be passing as an n minus 1 over here. So suppose if there are no houses, okay, if there are no houses, if n is less than 0, then what can be the sum? What can be the maximum amount of money that can be robbed from a house if there is no house? So it's 0. So we will be returning 0. Okay. Now if there is only one house, if there is only one house, that is n equal to 0. Why n equal to 0? Because because our array starts from 0 1 2 3. I am taking a 0 based indexing. Okay, so if there is only one house, then what will be the maximum amount of money that can be robbed? Just rob that house. Okay, because we don't have to worry about the restriction out there. So we'll be simply returning nums of n. Okay, right? Now suppose if we have two houses, okay, if we have two houses, right? So suppose if we have two houses, so what can we do? Like, what should be the basic understanding of it? Like, okay, just rob the house that has the maximum amount of money, right? So we will be just returning maximum of nums n and nums n minus 1. Okay, the nth house and the house previous to it, whatever is the maximum. Okay, whichever house is having the maximum amount of money, we will just simply rob that house and return that. Okay, so these are the base cases. Basically these are the base cases. Okay, now we will deal with recursive calls. So till here, is everything fine? Just let me know if everything is fine over here. Yes, sir. Max of n minus 1. So either you will rob the nth house or the n minus 1th house. Okay, so and you can't choose two houses consecutively, and we have only two houses, so one of them will be picked, right? Till here, if all the base cases are clear to everyone, just write a yes if it's clear to everyone. Okay. Okay, so now let me start with it. So what will be our element of choice? Okay, whenever we are making a recursion, so we have something called element of choice. So what is our element of choice? It is whether we will rob the nth house, okay, or we will leave it, right? So if suppose we have 3 houses over here, so if I am robbed, like I have a choice whether I will rob this ith house or I will not, correct? So let's take the first recursive call of if I rob the ith house. Okay, if I rob the ith house, I will be getting some amount of money if I rob the ith house. So now suppose let me take this example. Suppose if I'm robbing this house, okay, if I'm robbing this house, so I can add the value robbed in this house or the ith element to the I minus 2th element, right? To avoid this consecutiveness or the restriction which we have in our question. Okay, so I can say that if I am robbing the nth house, so the amount of money I will be having is nums of n plus tell me the maximum amount of money I can rob till the n minus 2th house. Okay, okay, so this will be our recursive call if we rob the ith house. Okay, now if we don't rob the ith house, okay, if we don't rob the ith house, so then also we'll be getting some amount of money if we don't rob the ith house. So if we don't pick this house, if we don't pick this house, then what is there? The maximum amount of money I can attain till I minus 1th house, that will be simply our sum. Okay, so we will be just making the call nums and tell me till n minus 1th house what is the maximum sum I can attain. Okay, and now we have to decide at the ith element what is the maximum sum I can attain. So that will be max of x comma y, right? If I take this house or if I don't take this house, what is the maximum sum I can attain? So if I take this, I have x as the sum, and if I don't take, then I have y as the sum. And obviously we want the maximum amount of money, so we will return the max of it. Okay, so this is the recursive code. Let me know if the recursion is clear to everyone. Let me know if the approach and the recursion is clear. Okay, fine. So now if you can see over here, it's a recursive approach. Okay, it's a recursive approach, and we will analyze the time complexity for this. Okay, time complexity for this. So if I take t of n as a function, so this call base cases takes constant time. So this will take nums n plus t of n minus 2, right? So nums n is constant, so we can ignore that. Okay, so it's t of n minus 2 and the call for this, if we skip the ith house, okay, so that will be t of n minus 1, right? Can you see that this is the exact same recursion for or the time induction for Fibonacci sequence? And if you solve it, it will turn out to be exponential. Okay, it will turn out to be exponential in 2 to the power something like, let's suppose k. Okay, so it's exponential, and we can surely say that exponential time complexity is seriously like not a good optimization of a problem. And but yeah, it's a brute force approach and it's correct, right? So let me just code down this approach for you, the recursive approach for you. Let me know if I can start with it and if this thing is clear to everyone. Okay. Okay, fine. So let me know if the editor is visible to everyone and the fonts are also good, like it's not too small, it's visible. Okay, cool. So as we said, like this is our input array, okay, and this is the value of n. So let me name the function as solve and let me pass nums and the value n over here. Okay, so this is our function that we will be taking. We'll pass our array and the value n. Okay, so we will be passing n minus 1. As I told, like we are taking 0 base like indexing of the array. So let us take the base cases. Okay, what will be our base cases? So first base case was if n is less than 0, then simply return 0, right? If n is equal to 0, that is we are having one house, then simply return the value at that house. Okay, if n is equal to 1, that is we are having two houses, then simply return the max of nums n, this house and the previous house, whatever house is having the maximum value, right? And now our recursive calls were there. So let me just quickly that. Yeah, so the first thing was if we rob the ith house, right? So we'll be taking the value at the current house, that is nums of n, and the house previous of it, right? Because we can't take two consecutive houses. So that will be nums n and n minus 2th house. Okay, so this is the take condition and this is the no take condition. Okay, so if we don't take the nth house, then what will be? It will be simply the answer we are getting till n minus 1th house. Okay, and we have to return the max of x comma y. Okay, so this is our input. Let me give input to it. So it's 4. Let me see the sample input. Now it's 1 2 3 1. Okay, it's 1 2 3 1. Okay, so this is our code, recursive code, and this is the input. Let's run and see if it's working fine or not. So there is some compilation error, vector was not declared. Okay. So if you want to include all the standard libraries, then this is the header for it. Okay. bit/std++.h. So let's again run it. Okay. Yeah, so it's not printing anything because I haven't stored the answer over here. I have to store the answer and print it as well. Okay, so for this input our answer should come as 4. See, yeah, so we are getting the right answer. Now let's go back. And since we were dealing with the brute force approach and this is exponential, so let us see, can we optimize it? Okay, so suppose we started with n. Okay, we started with n, and if you can see, the recursion is almost the same. Like either we will be going to n-2th house or we will be going to n-1th house. Okay, we will be making 2 recursive calls, that is the take condition and the no take condition. Okay, so let's suppose we take n equal to 4. Okay, so 4 will be divided to 2 and it will be divided to 3, then again it will be divided to 0 and it will be divided to 1. It will be going to 3 minus 2 1 and no take condition as 2. So can you see, we are again making the recursive calls, like we have redundant or overlapping subproblems. Here we have overlapping subproblems. We have already make a recursive call to 2. Okay, again we are making over here. So there are overlapping subproblems, right? Till here, let me know if you are getting the intuition of the problem and how we are approaching it, or if anyone is having any doubt, just ask me. Or if everything is clear, then I can move ahead. Recursive tree. Okay, so see, we had two conditions, either to take the ith house or to not take the ith house, right? So if we have 4 houses, right? If we have 4 houses, then for the take condition, our recursive call will be broken down into this. I will be calling the I'll be moving to the second house, right? Okay, let me just take it as a function, so then it will be much more clearer to you. Okay, so at 4, if we are taking that house, then we are moving to n-2. So 4 minus 2 is 2. So we are now saying that, okay, get me the result from f of 2. And if we are not taking, then we are saying that, okay, get me the result for f of 3. So if I break down in a similar manner, that if I am at the nth house, I will be taking it or not taking it. So you can see f of 2 is being called 2 times, one over here, and similarly for f of 1 and f of 1 as well. So can we say that if somehow we have already stored the result of this f of 2, then if again I have hit f of 2, then I don't have to recalculate it. I will be using my pre-stored results to get the answer for it. Is it clear now? Okay, cool. So I'm moving ahead. So we have already seen कि ठीक है, we had some overlapping subproblems, and if any by chance we could have stored the result of a particular recursive call, so we can reuse it. Okay. So now here comes the picture of memoizing it. Okay, memoization, and it's basically a concept of dynamic programming. Okay, so we will be using dynamic programming to store technique to optimize our solution and store our results for redundant recursive calls. Okay, so let me just tell you a good way to derive the memoization relation. Okay, so suppose you have written this recursive call. Okay, the way you have written your recursive call, the similar way you will be memoizing it. Okay, so I can say suppose I am taking a variable I that will be denoting the ith house. Okay, and I am taking an array name dp. Okay, that will be of size n. Okay, I am taking a array dp which will be of size n, and here I will be storing my results. Okay, redundant results, or I will be memoizing my results. So over here, can I say if I am at the ith house? Okay, if I am at the ith house, so the result over here will be, if I take this ith house, it will be max of nums I, comma, nums I plus dp of I minus 2, comma, dp of I minus 1, if I haven't picked this nth house. Okay, this is a very important memoization relation which we have directly derived from the recursive solution, or the recurrence we found out in our brute force approach. So is it clear? Let me know if this thing is clear to everyone. It's just the simple derivation of our recurrence and the memoization. Just say a yes or a no if anyone is having any doubt, so that I can move ahead. Okay, so let's move ahead. Okay, let's move ahead. So now we will be simply looking, and you just have to use your same recursive function to memoize as well. Okay, so suppose we declared an array dp of size n, and every element is -1. Why we are taking -1? Suppose if we are at dpi, we are at dpi, and its its value is -1, then it ensures that we have not made a recursive call on this nth house yet. Okay, so let me just write down the same function and solve. It will be nums will be passed, n will be passed, and dp will be passed. Okay, so our base condition remains the same. The base conditions remain the same. So it will be safe that if n is less than 0, then simply return a 0. We have no houses. If n is equal to 0, then return the element at the nth house or the only house. So it will be dp of n equal to nums of n. Okay, And if we have one house, then just simply return dp of, since base case takes only like constant time, so we are just not checking whether the nth house is already stored or not, right? Because they take a constant time. So here dp of n will be max of dpn, nums n, the nth house or the n minus 1th house. Okay, right? So here till here the things are same. Now before making the recursive calls, we will ensure that that particular nth or the f of n is not already calculated. Okay, so I will ensure that if dp of n is not equal to -1, that means we have already calculated it. We have already calculated the result. So we will simply return dp of n and we will not make any recursive call. Okay. Else our things are same. If we rob the nth house, then the result will be nums of n plus solve nums n minus 2 dp. Okay. And if we have not, then it will be simply solve nums n minus 1 and dp. Okay. Now in our dp of nth or at the nth house, now we will be storing, because it's a new recursive call for us. Okay, so now we'll be storing the result over here, and what it will be, it will be max of x comma y, right? And we will simply return dp of n, right? So this is our recursive call, and suppose we have made a call to this function, right? If we have made a call to this function nums n minus 1 and dp. Okay, if we have made a call, so my dp of n minus 1, what it will be storing, it will be storing the maximum amount of money with all the restrictions which was imposed I can get till the last house, and that will be our answer, right? If it's clear to everyone, let me know if it's clear to everyone. Yep. Any doubts, anyone? Then you can ask me. Then we will see the time complexity analysis for the same. It's important that you get the intuition why we moved ahead to recursion. Then we saw that there was overlapping sub problems, and then we tried to memoize it or cache our results, and then we just reused it. Okay. Okay, so now let me take the time complexity analysis. So if you can see, for each house we are making only one recursive call. Okay, only one recursive call. So I can say that for n calls, n houses, I am making n recursive calls only, but there are no redundant recursive calls, so our result will be not exponential. Okay, so our time complexity will be similar to big O of n. Okay, so we have reduced exponential time complexity to linear time complexity. Okay, so it's a linear time, we are able to solve it in linear time, right? But now can you see that we are the space complexity, we are using an extra array, and that was DP, right, to store our results, correct? So our space complexity is also big of n, right? Let me know if it's clear to everyone. The complexity analysis for this problem is clear to everyone? Okay. Now can we think of more optimization? Can we think of more optimization in space? Okay. Can we do more optimization in space? Can we do it in constant space, that is big O of 1? Anyone who wants to give their approach, they can. Any approach if you want to give. Just try to think of like what all values were of our use while calculating dp of I, and then try to think, can we optimize on space and do it in constant space? Okay, so let me start off with it if no one is having any approach. Okay, so if we see over here, for a dp of I, we were using, at max we were using dp of I minus 2, right, and dp of I minus 1, right? So can we say that we just need to focus on last two values or last two results, I would say, that is the result till ith house and the result till I minus 1th house. Can I say that? Hello D Violin. Try to be responsive and like give your approaches as well. Yeah, right. We can use only two variables to store the same and just get our results. Okay, so first of all, before going to this solution, the space optimized solution, let me just code down the memoization solution. Okay, so I will just simply write down the code. I was going to take a DP of nums, DP array of size n, and initially we'll be declaring everything as -1, and over here we'll be passing our I'm passing it as reference because I want to use the I want to get the same DP array which I have declared over here to get modified. Okay, so our base cases remains the same, and this will become DP of n equal to nums n, DP of n equal to max of this, right? And before making the recursive call, what we had to check, if DP of n is not equal to -1, that is we have already calculated it, just simply return DP of n. We don't need to make a recursive call for that nth house, right? And over here we have to just see DP of n is equal to max of, we are storing the recursive result for the nth house. Okay, and over here we have to simply do DP of n minus 1, right? And this was our input. So let's run this and see if it works fine. There are some compiler too few arguments. Okay, so here we are making a recursive call. Let's write DP. Alright, DP. Okay, now let's run it and see. Yeah, so we are getting the right answer, right? So this is the solution for or the DP solution, the memoization solution for the problem. Okay, let me know if that was clear to everyone. And now, okay, so let's begin with this approach or space optimized approach. Okay, so suppose this is our this is again our function that basically solves our, and we are having nums and n. Okay, so again, if n is less than 0, and that is not of our use because n will be always a positive or a natural number, right? So then also, if suppose n is 0, just return that, writing the same base cases again. Now take value 2. I am denoting value 2 for getting DP I minus 2. Okay, what we used to get from DP I minus 2, our value 2 will be taking that. Okay, so that is 2 houses before the current house, and value 1 I will be taking as DP I minus 1, that is 1 house that is just previous to that house. Okay, so if we have 1 house, then just store the result over here. Okay, and if n is equal to what shall I say, yeah, if yeah, if n is equal to 0, then just return this. Okay, return this value 2. Let's take value 1 for the previous, and that will be max of nums 0 and nums 1. Okay, and if there are only 2 houses, then just simply return value 2. Okay, value 1, sorry, my bad. Yeah, so just simply return value 1 over here, right? And now what we are left with, we are left with houses from index 2 to n, right? And for that we have to calculate it, right? Now can anyone tell me what's wrong over here in these base cases? Can anyone tell me what is wrong over here in the base cases? So basically if we are denoting n equal to 0, so n is our value. If n is 0, then it doesn't have any element. So if we are just simply passing n and not n minus 1, then it will be wrong, right? Because we have to just see if n is equal to 1, then only, or if our size of the num is 1, then only we can have a house, right? One house. So I have to just write 1 over here and just write 2 over here, right? If we have 2 houses, if we have 1 houses, we can't denote it by 0 and 1 over here, because here we are just simply using the n, or the number of elements we are having. Okay, so now over here we have houses 2 to n left, right? So what we will do is we will keep a variable as answer that will store our answer from I equal to 2 to n. Okay, from I equal to 2 to n, answer will be max of nums I. If we are taking, this is the condition that if I am taking the ith house, then I have to calculate the sum, or I have to add the sum of previous, or the previous to previous house of it, right? And that is stored in value 2, right? Or I will simply take the house previous to it, and that is having value 1. And now how will we update it? For value 2, that is the current house will become previous to previous house, right? So value 2 will become value 1 now, and value 1, the current house, will become the previous house, and it will be answer. And simply we will return or print the answer. Okay, so is it clear to everyone? And over here we have only used 2 variables, value 1, 3 variables we can say, value 1, value 2, and answer. And these are constant, these take constant space. Okay, these take constant space. Is it clear to everyone? Is this clear to everyone? Is this space optimized solution clear to everyone? Okay, I should explain again. So Abhishek, till the DP thing, okay, till we were using the DP thing, what we had to keep, what were the major previously stored results that we needed? So those were basically, if I come over here, those are basically DP of I minus 2 and DP of I minus 1. That is the result I was having for previous to previous house, and the result and the maximum amount of money that I can take till the previous house of the current house. Okay. So for that only, despite using the whole, taking a whole array and store the result, because notice one thing, we don't need DP of I minus 3 or DP of I minus 4 if we have come to a ith house, right? Those are of no use to us now. So why to waste memory in it, or why to use that space? So for that, we can simply take two variables. Value 2 over here I have taken, that will store or serve the same purpose was what was DP of I minus 2 was doing, and value of 1 what DP of I minus 1 was doing for us. Okay. And over here I am just saying that if I am having one house, then that will be nums of 0, right? And I will simply return it. Now I am storing the first house with value 2. Why? Because if I go to the third house, then this value 2 will be the previous to previous house of it, and the previous house of it will be value 1. Result will be value 1, right? That is the second house. If I explain over here is, suppose I have 3 houses. So if I am this house, if I am I3, I only bother about this I1 and I2. So if I start, I1 will be storing value 2 and I2 will be storing value of 1, right? And as we go forward to other houses, so suppose we started off with the third house, right? We started off with the third house. So now at the current nth house, or the ith house, if I'm taking it, then I will be taking the amount of money in that ith house and the value of previous to previous house of it, which will be stored in value 2, Or if I'm not taking that house, then it will be simply the previous house to the maximum sum I have got till the previous house, that is value 1. Now if I am at the ith house, consider this, if I have 4 houses and if I am I3, this was my value 2 and this was my value 1. Now for this house, for I4, the result here will become value 1 and result for this house will become value 2, right? So in this way I am updating it over here, and finally our answer will be storing the maximum result till the last house. Is it clear, Abhishek, now? Is it clear? Okay, good. So do I need to code it? Shall I code it as well? Just let me know if I shall code it. Only I will code only, no worries. Okay. So for this, okay, let's just keep that there. Okay. So I have this array. So I will be taking two values, value 2, value 1. Okay. If I have one house, so then as I said, I'll be storing, if I have one house, I'll be storing value 1 or value 2 as num 0, and if I only have one house, then I will simply return it. Okay. If I have only two houses, Okay, why I'm taking int over here again. Value 1, and it will be max of nums 0 comma nums 1, right? And if I am having only 2 houses, then just return value 1, right? And now we will be storing it answer, and for int I equal to 2 to n, that is from the third house, answer will be equal to max of, if I take the ith house, then it will be nums of I plus value 2, that is previous to previous house, or if I'm not taking, then just simply value 1. Value 2 will become value 1 for the next house, and value 1 will become the answer, and we will simply see out answer over here. Okay, let's run it and see. Okay, so it ran fine. So this approach took us the same time. The time complexity was big of n, and the space complexity was big of 1. So it was the most optimized solution for the problem, and this was a lead code medium problem of DP. Okay. So I hope so this question was good and you all liked it and you got to learn something out of it. If anyone is having any doubt, they can ask. Then I will end the session. Okay, thank you guys. Thanks a lot for attending the session, and meet you soon again all.